At Home Solutions, we love solving complex design challenges. We specialise in engineering, testing and product development. Many of our projects are in high-risk industries with substantial life safety elements. Our work ranges from new transport solutions and efficient timber connections to adventure rides and dynamic impact testing. We do everything from ideation and testing to final product compliance. Our clients come to us because they know we want them to succeed. We help them make a meaningful difference in their businesses, their industries, and in people's lives.
We do a lot of exciting work in the adventure industry. One of the cool products we've developed is called Switchback. It's a new zipline technology that can go around corners and even uphill, opening new opportunities for epic adventures around the world. Our Switchback design work ranges from complex mechanisms in the trolley all the way up to site and course layouts. Collaboration is important at all stages of design. We use 3D CAD modelling and PDM tools to learn and iterate our design ideas quickly. It's always exciting to show a client how their ride is going to look in real life, while exploring configuration options and final appearances on the fly.
One of the interesting projects we've worked on recently is testing to understand snapback events. A snapback is when a marine mooring line breaks under high tension. The parted lines can break the speed of sound in less than half a second. A snapback arresting structure is subjected to significant kinetic energy over a small area and over a short period of time, almost like a bullet. Gauging impact severity with conventional methods risks understating the impact, which has led to people using safety structures which may not be effective. A major mining company asked us to come up with a validated safety solution for their berths. This had never been done before. We used a world-first full-scale test setup to prove their design. Simulation was the key to this process, to understand both the line behaviour and the response of the arresting structure. Using the simulation model, we were able to break down what we observed in testing so we could develop consistency in the test platform and optimise the performance of the structure.
Often, more complex problems require us to take our 3D models further into an analysis cycle with tools like ANSYS or Creo Simulate. The analysis tools complement our in-lab testing, allowing us to build powerful, validated models to try new ideas and vary parameters. The advantage of this is our ability to have the same team members working between the lab and the computer, using evidence-based design methods to solve problems in real time. Tools that can keep up with us and improve that process are invaluable. Creo has been our primary 3D CAD modelling package for over 15 years. It helps us communicate complex ideas and collaborate on parts and assemblies within the team, especially when paired with Windchill product data management. These tools are vital to effectively design and problem solve for our clients. We have a wide range of projects, so the tools we use have to be flexible and adaptable. ANSYS allows us to understand complex loading and stress responses in our designs, especially when a prototype or system is too large to build and test. This helps us narrow down our solutions early and focus on delivering the end result with confidence. For example, we recently significantly improved the performance of our client's product using topology optimization in ANSYS. This feature allowed us to determine where material should be positioned to achieve the highest strength to weight ratio. As a result, we achieved a 50% increase in the strength of the component, while keeping the mass the same as the original part. Another area we've done a lot of work in is validating the performance of seismic energy absorbing components. This is especially important in New Zealand, where we are very prone to earthquakes. These components must achieve a required displacement without failure, but the limit, the displacement at failure, is not always known. So, we use a non-linear plastic analysis in ANSYS to determine the simulated performance of the component. We can then develop a more accurate and efficient test program to take into the lab before working on the actual product.
Many life safety products are designed to absorb massive energies or extremely large dynamic loads through controlled plastic failure or deformation. These events can occur in seconds or milliseconds. From an engineering perspective, they are extremely complex non-linear loading events. Examples include cars crashing into roadside safety barriers at 100 km an hour, rockfall protection systems being impacted with rocks travelling at 80 km an hour, or seismic restraints that absorb the loads generated by a 1 in 500 year earthquake event. In these cases, we use simulation with LS-DYNA to support full-scale testing. Simulations help us evaluate performance of different ideas before real-life testing. Once we've tested, we calibrate the model and use simulations to help predict performance of design variations or other situations.
Leap gives us access to product experts, for example in Creo or ANSYS, putting troubleshooting within easy reach. LEAP collaborate with us to develop new techniques for solving problems that push the limits of the tools, helping us lead the way in innovation.
If you want to know more about how we work at Home Solutions or our experiences in these projects, feel free to get in touch.